Hey students, welcome and thank you for tuning in to this video. I'm Dr. Loyal Zobi. In this video, I'm going to be talking about another lecture in the biomechanics class that I'm teaching. This is lecture 12 and I'm going to create a couple of videos about the topics in this lecture. I'm going to cover content and the material that is in chapter 10 in the textbook Linear Kinematics of Human Movement. In this first video, I am going to be touching base on the interrelationships among kinematic variables and how to distinguish between average and instantaneous quantities. In the following videos of this series, I will be talking about the effects of factors governing projectile trajectories and what are projectile trajectories and how to solve problems that are projectile trajectories and how to relate them to linear kinematics. I will start with the interrelationships among kinematics variables in the biomechanics class. I will start by talking about how do we define kinematics. The definition of kinematics is actually the shape, form, pattern, or sequencing of movement with respect to time. That's a very important thing to keep in mind, that we are relating different quantities to time, like position, speed, and acceleration. And also, it is a description of the appearance of motion as well. We are, as biomechanical engineers and biomechanists, we'd like to look at these kinematic variables that span both a quantitative and qualitative form of analysis. Kinematics is also referred as form or technique. That's something we want to keep in mind. First thing we would like to look at is displacement, and it is defined as the change in location or the directed distance from initial to final location. That's displacement. And it is a vector quantity, and it is measured in centimeters, meters, or kilometers. And it is different actually from distance. The definition of a distance is, if you look at this example of a skater that's moving in the field, so the distance the skater travels may be measured from the track left on the ice from the starting point to the ending point, which is the dashed line, green arrow that says the path of distance traveled. This is distance. However, displacement is measured in a straight line from start to finish, and this is the solid black line that is from this point to that point. So this is the difference between displacement and distance. So distance is scalar and displacement is a vector. So we need to keep those in mind. It's just a quick revision from physics. Also, so if we want to define what is a linear speed now. Now speed is a scalar quantity and it is measured in meters per second, and it is related to the distance covered by the time taken. It is distance covered by the time taken. And if you recall from the previous slide, distance is the the travel, the path of travel from start to end, which is the dashed line, and it's a scalar quantity. So if you took this distance divided by time, you will get the speed, which is another scalar linear quantity. We have multiple speeds that we use in biomechanics and use frequently in biomechanics. For example, we have running speed, and it's the product of the stride length multiplied by the stride frequency. And if you look at the image here to the right, it gives you what's the step length, which is between left and right legs during gait, and stride length is between right and right. Let's say in walking. So during running, a kinematic variable is also an influence. So these kinematic variables that affect the speed and stride length and stride frequency. You have muscle fiber composition, footwear, level of fatigue the subject is experiencing, injury history if the subject is injured or not, or the athlete, and also the influence and stiffness of the running surface. This is a huge factor actually in defining or that affects kinematic variables, which are speed, one of those factors. So if you look at step length and stride length, these two variables are specifically related to our definition of speed, because which is the distance over time, right? So stride frequency relates to the time factor, and the stride length relates to the distance factor. So that's how we measure speed, distance divided by time. So your speed is determined by how quickly your stride rate or frequency is and how much ground you cover in each one of these strides. That's how our running speed is defined. So we wanted just to touch base on this quantity and relate it to the anatomy and physiology of the human body. This is a figure that is showing you this change in stride length and stride rate with running velocity. So you can see that at the x-axis you have running velocity, and you can see, let's say on the right, you have this curve, which is the stride length. So you can look at the running velocity as a function of the stride length, and also you can look at the running velocity as a function of the stride rate. It's a compact figure, but you can get the information that you're looking for from it. And you can have such a graph that can be constructed from, subjects or athletes or a team that you work with, or for yourself as well. You can see what is your running velocity as a function of stride rate, and what is your running velocity as a function of stride length. So I would cover one of these curves and look at just only one of them as a function of the running velocity, and look at the values that we are getting out of it. Another thing, so we started with displacement and distance, then to linear speed, and now we're talking about linear velocity. Now velocity is a change in position or displacement, so it's not the distance, it's the displacement that occurs during a given period of time. It's the rate of change in location, and it's a vector quantity, and it's measured in meters per second. When we talked about speed, we were using the distance, which is scalar. Now when we talked about velocity, we are using displacement, not distance, to measure velocity as a function of time. This is defined as the linear velocity. Now, to give a biomechanics example, so the velocity of a swimmer in a river, the velocity now, it's a vector, is the vector sum of the velocity of the swimmer, that's this vector, and the current, the velocity of the current, that's that vector. So both of these vectors, this addition of these two vectors will result in what we call as the velocity of the swimmer in the river. So these are the things that you need to keep in mind, that velocity is a vector, and we treat it and we do the arithmetics based on that as well. So the last quantity that we would like to look at, linear quantity, is acceleration, and it is the rate of change in linear velocity, and it's measured in meters per second square. So yes, there's a typo here, it should be meters per second square. So the change of velocity over the change of time. So I'm sorry for the typo here. And if you want to look at, because it's linear now, quantity, we need to identify a reference from which we move in order to know if our acceleration is positive or negative. And here, this is an example. So if you look at the acceleration might be positive or negative, as I mentioned before, based on the direction of motion and the direction of change in velocity. So acceleration is equal to 0 when velocity is constant. That's something we need to know. And instantaneous velocity occurs during a small interval of time. Average velocity occurs over a distance time interval. So if you want to look at these two schematics on the top, so if you look at the top left one, if you're moving from negative to positive, right, that's in the direction. So that we are moving, let's say this is 0 and this is the positive x-axis, and we're moving to the right. If you are increasing your speed, this is small speed, and then high speed, your acceleration is positive, right? And if you're decreasing your speed, if you have high speed and then you slow your speed, this is negative acceleration. Decreasing speed means negative acceleration. However, if you're moving in the other direction, let's say this is still my origin, and this is the positive x-axis going to the right, and the subject is moving to the negative direction. If the subject is have slow speed velocity and then increased his velocity, we have a negative acceleration because we're moving in the negative direction. If the subject had high velocity and then slow down in the negative direction, then we have a positive acceleration. This is very important to keep in mind when we deal with accelerations, because it's a vector quantity. And this is an example of how velocity acceleration would look like. So sliding into a base involve negative acceleration of the base runner because the velocity is decreasing the subject, and we are assuming that he's moving in the positive direction from a reference point. That's how we identify this. So I hope that this was a quick overview of the linear kinematics quantities that we need to think of when we think about biomechanics. So if you reach this point, thank you so much. If you have any questions, you can leave them in the comments section, and I'll be more than happy to answer them for you. Thank you for watching. Until the next video. Bye.